So that first equation, log base x of 25 equals 2. I ask myself, what's my base? It's x. What am I setting my equation equal to? Well, that's 2. And then I'm going to set that equal to 25. All right. So just a matter of rewriting an exponential equation. Anybody have an idea how I would solve this? What can I do on both sides? Right, to undo a square, you can take the square root. So we saw this as a part of one of our examples. I can take the square root on either side, and I get x is equal to plus or minus 5. All right, either one of those answers is going to work. So make sure you're doing square root method, you take that into account. All right. We saw with equations, a lot of times we have to pull from some past information in order to kind of solve these. So we have to remember, different ways of factoring in some cases, different ways of using the square root method. Any way that we know how to solve for x is going to be useful. All right. Any questions about number 1? Number 3, same idea. Log base 3 of 81 equals x. So I'm going to rewrite this. What's my base? It's 3. What am I setting my equation equal to? It's x. And then I'm going to set that equal to whatever value is left over. So 3 to the x equals 81, right? So long as you remember that sequence of questioning, you'll be good for rewriting. That's always your first step. Now my x is in a different spot, right? Bless you. Now it's in my exponent place. So what I have to do in order to solve this is get common bases on both sides. So this is another type of question that we've seen before. What's that common base going to be? 3. So I'll leave the left-hand side as is. 3 to what power gives me 81? 4th. And when I have common bases, I can set my exponents equal. So I have x equals 4 for my final answer. All right. So in one regard, your x value is going to be your base. In another, it might be in your exponent. So again, just seeing a variety of problems. Any questions about number 3? And then number 5, again, very similar. Log base 4 of x equals 2. Well, I can rewrite this. This becomes 4 squared equals x. And our third type of problem that we could see involving one logarithm is when x is by itself. I don't have to worry about common bases or fractional exponents, any of that stuff. What's 4 squared? What's 4 times 4? 16. I just solved that accordingly, and that's my final answer. So 16 equals x. Any questions about that example? Expect to see 2 problems like that tomorrow, and you might see a variety of where your x is located in each of those problems, okay? Yeah, does anybody got one? Cool. So now that we've seen these, in number 7, let's take a look at that. How would I rewrite that so it's an exponential form? So my first step here, number 7, how would I rewrite that? Right. So x equals 64 to the power 2/3, or 64 to the 2/3 equals x. Either way. If something's raised to the 2/3 power, right? Anytime we see a fractional exponent, that means that I have a radical with that number underneath. What root am I taking? In other words, what's the index here? 3. So I'm taking the cubed root, which means I'm squaring inside. Well, what's the cubed root of 64? What number can I multiply by itself 3 times to get 64? What was it? 4. Right, so we start with the root. Well, we start by taking whatever that root is of that number. And then what's 4 squared? What's 4 times 4? 16. Good. Awesome. Any questions about anything from this first page where we are involving just one logarithm? All right. Let's flip over to the second page. Log base 5 of negative 3x equals log base 5 of 3x plus 6. So like I said, we're going through all the odds. Evens will be due for homework, just so you're aware. When we have logs on both sides, so I'll walk this first example on my own. We have logs on both sides. We have to recognize that they have the same base. And if they do, we take each value, the negative 3x, the 3x plus 6, and we're going to set those equal to each other. All right. So I'm going to start this equation by doing just that. I have negative 3x equals 3x plus 6. And I can just solve this like any linear equation. So what should I do on both sides? Subtract 3x. And I have negative 6x equals 6. Get x by itself by dividing by negative 6. My answer is x equals negative 1. All right. So like we've seen in the pattern that we saw last week, not only with equations, but inequalities, hopefully we recognize that when there's logs on both sides, they're a lot easier to work with comparative to just dealing with one logarithm in general. All right. Any questions about that example? All right. Let's go to the next example. What should I do to start this problem for number 11? I have log base 15 of x plus 7 equals log base 15 of negative x minus 3. What should I do on both sides? Or what can I do? X plus 7 equals negative x minus 3. Good. Every time you'll have either a linear or quadratic equation, which is what we're going to see in the next example. And for this, what should I do? How would I solve this? How would I solve this? Nick? Add x to both sides, subtract 7. So I have 2x equals negative 10. I forgot to clock in. As soon as I called, I was like, oh, God. Divide by 2 on both sides here. I get x equals negative 5. That's funny as I see people walk past that thing every day. And I walked to the front office just for that reason. I was like, is there anything I need to do besides? Because I don't know. I never came in late before. So I was like, do I need to sign in besides like that? But when I got here, I was trying to do all my own stuff. So I completely forgot. Everybody good with that example? All right. Let's move on to the next one. Log base 19 of 2x minus 6 equals log base 19 of 3x plus 6. How would I start solving this logarithmic equation? Got logs on both sides. They have the same base. What can I do? Nick? Good. 2x minus 6 equals 3x plus 6. Go through my process again. Let's get all of our variables to one side. It doesn't matter necessarily what I do for equations. So I'm going to subtract 2x and subtract 6. And I'll get negative 12 equals x, which is nice. I don't have to worry about dividing or anything like that. So that is my answer. Negative 12 equals x. All right. Any questions about 13? All right. How this changes in 15, what do we notice? Because we're still dealing with logs on both sides, but what's different about these examples? They're squared, right? X squares. Powers, exactly. So these now become, instead of linear equations, which are a little bit easier to work with, they become quadratic equations. And what we saw with quadratic equations is that to solve for these, we need to be able to factor. All right. So I'll go through 15 and then we'll do 17 and 19 together. Okay. In 15, our thought process is still the same. So I have log base 14, 4x squared plus 3x equals log base 14, 18 plus 3x squared. All right. So I can still drop everything that I'm taking the log of down into an equation. So I have 4x squared plus 3x equals 18 plus 3x squared. All right. Excuse me. But now instead of trying to get all of my variables to one side, constants to the other, right? That's what we do for linear equations. With quadratics, what we want to do is get all of our terms to one side. So in order to do that, what I'm going to do is subtract 3x squared and subtract 18. Just get everything over. And the reason I'm going from that side to the other is because I want to make sure that the number in front of x squared is positive. Otherwise, it's going to be hard for me to factor. And we saw that in some of our examples before. So subtract 3x squared, subtract 18. I'm going to combine the 4x squared minus 3x squared. So that's going to give me x squared. The 3x I can't combine anything with, so that's going to come down and be the same. And then the 18 will be brought down as well, since I can't combine that with anything. Everybody with me so far? Any questions? All right. Expect to see a problem like this tomorrow with factoring. So please make sure that if you do have any questions with that process that you ask now. All right. When factoring, we ask ourselves, what two numbers will multiply to give me that number there? So the last negative 18, add to give me 3. And we had a couple different rules involved with this. First off, we can always fill in the x and the x, right? But when we're multiplying to get a negative number, what does that mean about the signs? One's positive, one's negative, so I can fill that in. And it makes it a little bit easier for me now to choose the correct factors. All right. What two numbers will multiply to give me negative 18, add to give me positive 3? Negative 3 and positive 6. And if it helps, you can list out the factors. So I have 1 and 18, 2 and 9, 3 and 6, right? Those are all my factors. I can just, plug and try and figure it out. Positive 6, negative 3. Is my problem over from this point? Right. On the quiz tomorrow, don't just get to this step and say, oh, the answers are 6 and negative 3. You have to take each factor and just set it equal to 0. In other words, you really just have to change the sign of whatever that factor is. So I have x plus 6 equals 0, x minus 3 equals 0, subtract 6, add 3. I get x equals negative 6, x equals positive 3. And those are my final answers. All right. Any questions about that first example? So I can set those values equal, get everything to one side, factor, and then set those factors equal to 0 to finish my problem. So long as you take it step by step, you should be fine with each of those. Okay. Let's move on to the second example. Log base 19 of x squared plus 33 equals log base 19 of 13x minus 3. I have logs on either side. They have the same base. So what should my next line look like? What do you think? X squared plus 33 equals 13x minus 3. Good. So I just bring those values down. I get rid of the logs entirely. Okay. And whether it's inequalities or equations, that's going to be your first step. Now what I need to do is get everything to one side. So I have minus 13x plus 3, minus 13x plus 3. So my new equation is x squared minus 13x plus 36 equals 0. Okay. Everybody with me so far? Everybody see how I got to that point? All right. Well, my only way to solve this is to go ahead and factor. What are some factors of 36? Why don't we go through that process just so it helps if we ever get confused going through the quiz. Some factors of 36. 6 and 6. What about 1 and 36? 3 and 12. Good. 2 and what? 18. 4 and 9. You got anything else? That's it, right? We got everything. All right. If it helps, list those out. All right. I have x and x. Now I'm multiplying to get a positive number. So what does that mean about my signs? What's that? In this case, they're going to be both negative, right? But they're the same. It's going to be the same sign. Because in this case, because that middle number is negative, they'll both be negative. If the middle number was positive, they'll both be positive. All right. So it's always the same sign when you're multiplying to get a positive number. So now my question is, what two numbers should I plug in? What two numbers are going to multiply to give me positive 36 and add to give me negative 13? 9 and 4. Good. Everybody see how we did that? Take each of those factors, set them equal to 0, and you get x equals 9, x equals 4. And those are your final answers. All right, just add the 9 over, add the 4, and you're good. Any questions about that example? All right. Why don't you take a couple minutes? I want you to do 19 on your own. All right. Take a few minutes, go through that. We'll go over it and then we'll move on. We just have 2 more problems after that. Okay. And then we'll give you the rest of the time for some independent practice to get through the remaining problems that will be due for homework. All right. In 19, you are going to be factoring, or actually, you're going to be doing something a little bit different than factoring. See if we can figure this out on our own. Okay.
Oh, wait. Actually.
Who's that? So this is something that we're going to be wrestling with a little bit. It's not like some of the examples that we just did. But hopefully we can kind of at least go through the process and see what the difference is. The steps are still the same, right? We're still setting it equal on either side. But then some things might cancel out that are a little bit different. Take another minute or so to wrap up, and then we'll go over this. What's that? Okay. Yeah, I was going to ask you a question about that because I guess, I have to go through and do that for my other classes as well. And I wasn't sure. When do they do? Friday? Wednesday. Jeez. Okay. So I got to do that today. All right. And failures, anything below 65 for the year or just for this market period?
So I'll show you the form.
Okay. I feel like it's going to be a decent amount, right? Could be.
I'll let you know.
All right. All right, let's go over this. What's the first thing that I need to do here on both sides? Or what can I set equal to each other in number 19? Nick? Yeah. So what should my next line be? Good. What should I do now? What should my objective be? Subtract 49, 3x. So I want to get everything to one side, right? Steps haven't changed yet. So I subtract 3x, subtract 49. But then what we can see is the 3x and the negative 3x cancel. I have x squared minus 49 equals 0. So we lose that middle term. If this is the case, if you see a question like this tomorrow, I still have the x squared and that term there, right? I'm not going to be able to factor this. But what I can do is what? Was anybody able to figure out what to do here? Nick? Good. I can add 49 on both sides. And this is something that we saw actually in example 1 with our square root method. It's the square root of 49. Right, we could have. I'll square root both sides. And what's the square root of 49? Okay. But what do I need to include anytime I do the square root method? plus minus, right? So it's plus or minus 7. I still get 2 answers that will satisfy that equation. Excuse me. So make sure that anytime you use the square root method, you include that plus or minus in your final answer. Concern yourself more with the factoring idea, but I wanted us to kind of challenge ourselves a little bit here and see if we could, wrestle with something that we haven't seen in a little bit, which is that square root method for solving. All right. Any questions about logs on both sides and quadratic equations? Okay. Last 2 problems we're going to do now are inequalities. This is something that we touched on Thursday. We did a little bit of practice with it on Friday as well. For inequalities, the amount of things that we need to take into account isn't necessarily as wide as maybe equations. For example, when I'm dealing with 1 log, my x is always going to be in the same place, right? When I rewrite this. So in example 21, what should my next line look like? Because I'm still going to rewrite it as an exponential, but what would my next line be? Exactly. It's always going to be whatever that base is raised to this number. That'll never change when there's 1 logarithm involved. And you can keep your x on the left-hand side of the inequality as is. Okay. Bless you. So first step, again, rewrite it as an exponential. What is 2 to the 4th power? 16. So I have x is less than 16. Exactly. So my next question is, if anytime I have less than, what do I need to include in my answer? And as Keegan said, you have to include that 0 is less than x, which is less than 16, right? The reason for that, and I'll do this again, if I were to sketch the graph of the logarithmic equation, this is what it would look like. So this line here, and my line approaches but never touches the value of 0. So because of that, anytime that we have less than, we need to make sure it's between 0 and whatever that number is. So my answer here is 0 is less than x, which is less than 16. And that's how I would finish writing my inequality. Expect to see a question like this tomorrow on the quiz where you're going to have to type in the actual inequality itself. All right. Any questions about that example? If it is greater than, you can leave it as is, which we're actually going to see in the next example, except what do we notice that's different about 23? What's that? It's greater than, but what else is involved? Do I have 1 log or what else? I have 2 logs, right? On either side. So the way that I solve this, the same way I solve equations, what would my next line be? Seven x minus 6 is greater than. Exactly. Good. All right. So you take each of those values still, so long as I have the same base for either of those logs, I get rid of them. And I have 7x minus 6 is greater than 4x plus 9. And what's also nice about logarithmic inequalities is that we're never going to be dealing with quadratics. It's always going to be linear inequalities. So what I can do here is get all my variables to one side, constant terms to the other. So what should I move around? Subtract 4x, add 6. I get 3x is greater than 15. So what's my final answer? X is greater than 5. Good. All right. You see, very similar to equations, the process for inequalities is almost identical, if not a little bit easier, because like I said, there's less to take into account when we're dealing with 1 logarithm, and we're only dealing with linear inequalities when we have logarithms on either side. All right. Any questions about that last example? Anything at all that we covered in class today? Okay, very quickly, let's talk about what the mini quiz looks like tomorrow. It's 5 questions, 15 points. Okay, so kind of in between some of the mini quizzes that we had before versus some of the quizzes that we had that covered multiple sections. This is the last big chunk of points that you're going to have for the marking period. All right, so just kind of keep that in mind. Two of the questions will be, one logarithm equation. There'll be a question with one logarithm equation, logs on both sides, and then one singular log inequality and logs on both sides for an inequality. For the equations, you're just gonna have to type in the value that you find or values if you're, factoring for your answer. And then for the inequality, you're gonna have to type in the entire inequality expression, not including any spaces or anything like that. Keep in mind if it's something that's less than, you have to include that 0, so on and so forth. Just remember all your rules. Tonight for homework, what I need you to do is complete all the problems not done in class. So let me go to today's folder actually, just so we're aware of that. So if you go to Monday, 6-7, you see there the 7-4 review. This is probably the last homework assignment for this week because on Thursday and Friday, we're just gonna be doing some in-class stuff. So make sure that you get this done. It's all the even problems from class. All right, so hopefully you're following along with the odds. You don't have to worry about those. And it'll be a good review for you heading into tomorrow. Everything that's on here is gonna be something that you'll see tomorrow. So, it'll be constructive for you. All right. Any questions about anything that we covered in class? Any questions about the quiz tomorrow or the homework assignment for tonight? Okay. For those of you that are at home, you can go ahead and sign off. Have a great rest of your day. Get your assignment done. I'll see you tomorrow. For those of you that are in here, just wait until the bell rings. You can start this since you have a decent amount of problems to complete. Any questions that you might have, I'll be able to ask or answer for you. All right. Take care. Have a great rest of your day for those of you that are at home.